Hello friends, welcome to today's video. So today we'll be solving some of the electronics and communication engineering as well as some of the questions related to electrical engineering. So starting with the first question says consider a common emitter current gain of beta. Beta has been given as 150 and a base current of IB of 15 microamps. So IB has also been given as 15 microamps. And if the transistor is biased in a forward active mode, the collector and the emitter current are. So what we need to find is the collector current and the emitter current. We know that from the equation for a common emitter configuration, IC is equal to beta IB. So beta is given as 150 and IB is given as 15 microamps. So which is equal to 15 into 15, 225 into 10 to the power of minus 6. So which is nothing but 2.25 milliamps. So this is nothing but the collector current. Now emitter current is nothing but 1 plus beta IB, that is 1 plus 150 into IB is given as 15 microamps. So this is equal to 151 into 15, which is approximately comes to 2.27 milliamps. So the correct answer is 2.25 milliamps and 2.27 milliamps. Next, so the effect of reduction in the effective base width due to the increase in reverse bias voltage of a BJT. So in case of a BJT in the transistor, so what they are saying is between the due to this effective reduction of base width. We know from the phenomenon the early effect, what happens is that the base width will actually decrease when we increase the reverse voltage of the BJT. So this is also known as the early effect. So this is the straight away definition of the early effect. Next, so one form of MOS logic circuit that minimizes the power dissipation and maximizes the device density is, there is one special configuration which is known as a pass transistor configuration, where the power dissipation can be reduced in the case of this CMOS circuits. Since NMOS is one of the configuration of this CMOS circuits, so pass transistor logic is used for this, which also maximizes the device density. So from the given options, the correct answer is the pass transistor logic. Okay. Next, a DC voltage supply provides a 60 volt when the output is unloaded. So no load voltage is 60 volts, and when it is connected to a load, the output drops to 56 volt. So when the load is given, the voltage drops to 56 volts. Then they are asking us to find the voltage regulation. We know from the equation of the voltage regulation is V no load minus V full load by V full load. So in that case, which is nothing but the 60 minus 56 by 56. So that will correspond to 4 by 56, 57. So it come to around 7.1%. Okay. Next, in the optical communication, the maximum angle in which the external light may strike the air glass and still propagate down the fiber. So in the case of a fiber, what they're saying is, what is the maximum angle? Let's say we have this fiber. So what is the maximum angle at which the light rays can enter so that this light will propagate inside this fiber? So this is nothing but the definition of the acceptance angle. So acceptance angle is the one which defines this one, the amount of maximum angle that light can pass through this optical fiber. So the correct answer is the acceptance angle. Whereas numerical aperture, it defines the ability of the fiber, where it gives the maximum angle at which the fiber will allow the light to pass. Next, which of the following materials is having the highest electrical conductivity at the room temperature? So electrical conductivity is highest in the case of a silver. We all know that silver is a good conductor of electricity, and among all these, silver is having the best conductivity. Next, in the ABCD parameters, A and C are called. So ABCD, which is also known as the transmission parameters, we know that the equations are defined by, for a two-port network, V1, I1, and then this is a V2, I2. So in this case, how this V1, I1 and V2, I2 are related are with these equations. That is V1 is AV2 minus BI2, I1 is CV2 minus DI2. So A and C are called. So from this definition, we know A is nothing but the V1 by V2 when I2 is equal to 0, and when C is nothing but the I1 by V2 when I2 is equal to 0. So V1 by V2 A is nothing but the voltage ratio, since it is a ratio of the voltages V1 by V2, and C is nothing but the I1 by V2. So it is admittance parameter. So from the options, so it is nothing but the voltage ratio and the transfer admittance. So this is the correct answer. Next, a coil has a resistance of 10 ohms and inductance is given as 15 henries. The voltage at the instant when the current is, so a coil is nothing but a resistance in series with the inductance. Okay, so resistance is given as 10 ohms and inductance is 15 ohms. Then in this case, what is saying, the voltage at the instant when the current is 10. So when the current is 10 amps and the current is incremented of 5 amps per second. So in this case, you know, the total voltage is nothing but the voltage across the resistors plus the voltage across the inductor. So this is nothing but the 10 amps into, since the it is in series, so current is 10 amps. So 10 into 10 plus the current is nothing but L di by dt in the case of an inductor, which is nothing but 100 plus 15 into the rate of change of this current di by dt is given as 5. So which is nothing but 100 plus 15, 5 75. So it comes to 175. So 175 volts is the correct answer. Next, an amplifier has a signal input voltage Vi is given as a 0.25 volts and draws a current of 1 milliamp. So the current input current is 1 milliamps from a source. If the amplifier delivers the 8 volts, so the V0 is given as the 8 volts to a load of 10 milliamps. So I0 is also given as 10 milliamps. The power gain, we know that the power gain is nothing but the output power by the input power. So what is the output power is 8 volts into 10 to the power of minus 3 divided by input voltage 0.25 into current is 1 milliamps. 80 by 0.25, this will corresponds to 320 value. So the power gain is nothing but the 320. Okay. Next, the output voltage for a 5-bit ladder DAC for a digital to analog converter, the digital input is given as 11010 and assuming the 0 volt as 0 volt and 1 is given as 10 volts. So that means the minimum resolution they have given as the 10 volts. Then they are asking us to find out the output voltage for this input. This 11010 corresponds to decimal as the 26 value. Okay. We know that the resolution is nothing but the full voltage by the 2 to the power of n. So 10 volts by 2 to the power of n is 2 to the power of 5, since 5 bits are used. So 10 by 2 power of 5 is the resolution. Then for this voltage, then for this input, how much is the voltage? Then this is nothing but this times into this 26. So that will corresponds to 8.1 volts. Next, which of the following types of instructions will be used to copy a source to the destination location? So what they're saying is from one location to another location whenever we are copying it. So copying is nothing but a type of a data transfer. So we are transferring the data from one location to other. So if we see the options, So it is a type of data transfer. So the correct answer is the data transfer instructions. Next, a cascaded arrangement of flip-flops where the output of one flip-flop drives the clock input of the other flip-flop. So what they are saying is the output of one flip-flop is driving the clock of the other flip-flop. So this is nothing but the definition of the ripple counter. Okay. So the correct answer is the ripple counter. Next. An amplitude modulated amplifier has a radio frequency output of 50 watts at 100% modulation. So the output power is 50 watts at modulation at 100%. So mu has been given as 1. The internal loss in the modulator is 10 watts. So the internal loss is the 10 watts. So in this case, the unmodulated carrier power is, the power loss is given as the 10 watts and the radio frequency is, the output is 50 watts. So the total power is corresponds to the loss plus the output power. So which is nothing but the 50 watts plus the loss is 10 watts. So the total power is 60 watts. We know that PT is equal to PC into 1 plus mu square by 2. So in this case, PT is coming as 60 into PC into 1 plus mu is 1 by 2. So which is equal to, then what is the value of PC we are getting is 3PC equal to 60 into 2 by 3. So 20 into, so that is 40 watts. So 40 watts is the correct answer. Next. For a Gaussian and white channel noise, the capacity of a low-pass channel with a usable bandwidth of 3000 Hz. So bandwidth has been given as 3000 Hz and the signal to noise ratio has been given as 1000, just 10 to the power of 3. Then the channel output will be. So the channel output is nothing but the capacity of the channel. We know from the channel capacity is given as a bandwidth times the log 2 into 1 plus S by N. So if we substitute the value C equal to 3000 into log to the base 2 plus 1 by S by N is 10 to the power of 3. So this will come to approximately equal to, this will come to approximately 10 and this is 3000. So the total will be approximately 30,000 bits. So the correct answer is 30,000 bits per second. Next. The magnitude and the phase relationship between the sinusoidal input and the steady state output of a system is. So we know that this is nothing but like when you are calculating the magnitude response with variance to the frequency, so that is nothing but the frequency response. So from the given options, this is nothing but a frequency response. Next. A transfer function have all its poles Zp and the Z0s, which is Z0, only in the left half of the S-plane. So when all the poles and zeros are in the left half of the S-plane, then this corresponds to the minimum phase function. This is from the definition. So from the given options, the correct answer is the minimum phase function. Next. The frequency where the magnitude m has a peak value in the frequency response. So whenever the peak value is attained only at the frequency of the resonant frequency. So this we know very well. So from the given options, the magnitude, the peak value attains at the resonant frequency. So from the given options, the correct answer is the resonant frequency. Next. Convert the binary number into the gray code. So in order to obtain the gray code from the binary number, what we do is we take the first number and then do an exclusive OR of the next number in sequence. So we'll take 1 as it is, then 1 exclusive OR 1 is 0, then 1 exclusive OR 0 is 1, 0 0 is 0, 0 0 is 0, 0 1 is 1, 1 1 is 0 and 1 0 is 1. So the total gray code is 1 1 1 0 1 0 0 1 0 1. So this is a gray code. Next, which of the following statements are correct? An address generated by a CPU is commonly referred to as physical address. Okay. An address seen by the memory unit is commonly referred to as a logical address, and the runtime mapping from the virtual to physical address is done by MMU. So for the CPU, it sees a physical address, whereas MMU, it does a translation of the logical address to the physical address. So this logical address is nothing but the virtual address, and physical address is actually physical address. So MMU does that. So the address generated by CPU, it is a physical address, and address MMU is commonly referred as logic. So this is also correct. The runtime mapping of VA to PA is done by MMU. So this is also correct. So all the three are correct. So the correct answer is all of the above. Next. In a cache with 64-byte cache lines, how many bits are used to determine which byte within a cache has an address points to? So the total cache line length is 64 bytes. So 64 into 1 byte is 8 bits. Okay. So in this case, how many bits are used to determine this one? In order to know the bits, we'll use a, so the length is equal to the 2 to the power of n. So 64 is 2 to the power of n, then n will correspond to the 6 bits. So 6 bits are used to address this cache line. Correct answer is 8. 6. Next. Ground waves progress along the surface of the earth must be polarized. So typically the ground waves, we are normally using a vertical antennas so that the waves are vertically polarized. So in this case, the waves must be, since the antenna is vertically oriented, so the waves are also vertically polarized. Next. The characteristic impedance of an 80 centimeter longless line having a inductance of 0.25 microhenry and capacitance of 100 picofarads will be in ohms. So the characteristic impedance we all know is Z0 equal to root L by C. So here it is given as 10 to the power of minus 6 by L C is 100 into 10 to the power of minus 9. So if we do a calculation, then that will corresponds to 50. 25000, which is 50. This is the correct answer. Next. A controller that takes control of the buses and transfers the data between the source and the destination. So from the source and the destination, bypassing the microprocessors. So whenever we do a data transfer between it takes the control of the buses and bypasses the microprocessor. So this happens in the case of a direct memory access, DMA. So the DMA controller, what it does is directly from the input-output devices to memory, the direct transfer happens bypassing the microprocessor. So this is done by the DMA, which is the DMA controller. So this actually increases the efficiency without actually using the microprocessor. So in this time, microprocessor can do some other task. So this is the advantage. Next, the instructions BC 0 by 15 means, we know that there is no such instruction as BC. So in this case, what will go to the processor directly jump to this address. So it will jump to 15 bytes related to the program counter. So the program counter will point to the current instructions, and that is saying to go by 15 bytes. So then it will jump to this 15 PC plus 15 bytes. Okay. Next. Which of the following instrument is useful while measuring the optical power as a function of wavelength? So we are measuring the power with respect to wavelength. So wavelength can be correspond to frequency, and like we know that But all the power is varying with respect to the frequency, and then this can be known, this is nothing but the spectrum. So we can use the help of a optical spectrum analyzer, we can analyze the spectrum and then we can measure the optical power. So this is the correct answer.